Hi, let us try to understand in this session as to how a silicon control rectifier, this is silicon control rectifier, how a silicon control rectifier, in short we call it SCR, works. It can be used in DC, it can be used in AC also. For the time being we have started with the DC part of it. And the DC part, what we see is we have taken a 12-volt battery and then we have taken a switch and then a push button switch here, another push button switch here, and a gate arrangement and a load connected in series with the SCR, anode cathode. This is a load connected. You see, all of us know that a silicon control rectifier, once triggered, that means once the current flows through the gate to the cathode, this is cathode, this is anode, okay? So once the current flows from the gate to the cathode, then only this conducts. Otherwise, it doesn't conduct. Unlike a diode, you give this side positive, this side negative, it conducts. People call it forward bias, reverse bias. Let's not go into those typical words to get confused. A diode or an SCR, whatever it is, or a diode, current flows this way, current doesn't flow this way. That's all. So they call it forward biased and reverse biased. So they means our good engineers, they call it forward biased, reverse biased, only to confuse people with high sounding words. There is nothing great in that. It's only current flows this way, current doesn't flow this way. Okay, right. So now coming to the SCR, this is the gate. What I said, the current has to flow in the gate to cathode for this to allow the current flow this direction. Now how the current will flow once the gate is triggered? It will start from positive, this way, goes this way, this way, this way, and this way. Because there is no other path. This path is open by the switch, and this also. And how it flows? Only when the gate current flows. Now we'll see that. Sorry. What is happening? Right. Now let's see. The positive is denoted by a red line, the negative is by blue line, and what I said that yes, once I trigger this, only trigger means I pass the current once and then I can remove it. Like for example, when I press this and I removed it, you see, once it was triggered, now the current starts flowing. There is no current flowing in the gate now. Because once I have triggered means I have allowed a current to flow in the gate and the cathode, the SCR behaves like a diode. It conducts. Right? Then when can it stop? It should stop also. The stop arrangement can be done by two methods. One is I momentarily open this and then close again. Now see, the current stops. I have momentarily opened it and I closed it again and the current stops. Now unless I trigger it again, it doesn't flow. I have triggered means I have just passed for a brief period the current in the gate to the cathode. So this follows again. It can also, in this conducting stage also, it can be switched off. How? I apply a negative voltage. I have taken a one cell battery which is 1.5 volts. I have taken a negative connection in the sense, see, when the current is flowing, this side is positive, this side is negative. Now if I apply a voltage in the reverse direction, this side positive and this side negative to this switch, what will happen? This SCR will perforce go to off. Now let's see that. You see, now the SCR again has gone to, though this path was there, the SCR has again gone into out of conduction. Like to see it again? Let's see this. Current flows, stops, flows, stops, or flows, momentarily I have made it, stops. This is what is SCR. There is nothing great in this particular component, But when we use it for AC applications, then things are different. We will see that in subsequent slides. Let me go over to this. Hi. Now let's see the same thing when we use it in AC. We have an AC supply here. Same arrangement. We have a lamp, of course, and we have a 100 ohm resistor here. Let this be off condition. Okay, the same thing, same situation. Now let's see how it works in AC. Right, I have connected a CRO. What CRO? I connected a CRO at this point. I connected a CRO to this point. Channel 1 is connected to this point, so I get AC supply here, right? And we know it can conduct only when the positive, this side is positive, this side is negative, as if in a half wave rectification. So when I trigger this, or when I pass the current through the gate to cathode, or I keep it pressed, you see this blue line which you find here is the half wave which is going. And if you like to see it better, and we can even put it down. Yeah, I can see this is my half wave which I am getting, because I have triggered it permanently. That means every time every pulse is coming, the current is flowing between gate to cathode. Okay, let's now see if I momentarily press it and release it. All right. It's only when the current flows continuously, because every positive half cycle the current flows from gate to cathode, and then 1 is there. And when this comes to 0, when the supply comes to 0, obviously the current through the SCR comes to 0, so it goes out of conduction from when this side becomes positive and this side becomes negative. That means from here to here, this side is positive, this side is negative. So this, and same situation, we have it in conduction mode, and if I apply a voltage here, you see the full voltage appears across this, and this is because this conducts directly as compared to the other DC circuit that we had shown. Anyway, so the objective of this is that how it behaves in AC and how it behaves in DC has been clarified. Thank you.